around it is in the form of concentric circles.
Magnetic field around a straight conductor can be understood by the following activity. We will take a flat cardboard and cover it with a white sheet of paper. In the middle of cardboard, we will make a hole and through it pass a thick wire and connect it the ends of wire with a dry cell. You can see from positive to negative current is flowing in the wire. Now we will plot the magnetic line of force around it with the help of compass, and we will observe that these line of force are in the form of concentric circles, and the direction of line of force will be clockwise. The experiment, if we repeat it again, but now the current is passed in opposite direction, means bottom to top in the wire, then the line of force will be in anti-clockwise direction.
We can apply right hand thumb rule to measure the direction of magnetic field lines. Let's see. Right hand thumb rule states that if we imagine that we are holding the current carrying conductor in such a way by our right hand that thumb is in the direction of current, like this. Current is flowing from this end to this end, A to B, and we are holding this conductor by our right hand, that thumb is in the direction of current, then the curvature of our fingers will point to the direction of magnetic field. So here this will be the direction of magnetic field. Is this okay? We will place this conductor here and we will imagine that we are holding it with our right hand in such a way that thumb is in the direction of current, then curvature of fingers will point to the direction of magnetic field. So this is the pattern shown by the magnetic field in case of straight conductor, and the direction of this magnetic field will be given by right hand thumb rule. Similar in case of a circular loop. A circular loop acts like a straight conductor at a section. Say if I talk about any section, say this is the section here and this is the section, and current is flowing from A end to B end, and current is going like this. Then magnetic field pattern will be, if I apply magnetic field at this section P, then this will be the direction of magnetic field lines, and these magnetic field lines curves becomes larger, and in the middle it will become straight. And here if I apply, the current will be direction of magnetic field in this loop will be downward. Students, always remember this pattern in which current is flowing clockwise, then it makes a south polarity. It behaves like a south pole, and if current is flowing anti-clockwise direction, the similar in case of bar magnet, there are two poles, it will behave like a north polarity. This pattern is similar to the magnetic field pattern shown by a bar magnet, in which these type of magnetic field lines are formed. And inside it is south to north. So let's see with the help of animation how magnetic field is generated in case carrying loop. Thank you.
This is the setup for seeing the magnetic field around a circular coil. You can see the side view of this setup. There is a battery. There is a copper wire in the form of circular loop. It is placed in a cardboard sheet, and these are the components of the circuit: conductor, iron filings, a plug key, battery, and the iron fillings are there. This is the side view. This copper coil is passed through the cardboard sheet. We will sprinkle some iron fillings near the conductor. We are placing iron fillings in an irregular pattern, and when we supply current by inserting the plug key and current starts flowing, you can see the magnetic field lines arranged in a way, in a pattern, in the form of concentric circles. This is the pattern shown by magnetic field lines in case of current carrying circular coil. We can see that magnetic field line of force around the hole at A are in anti-clockwise direction, and however the magnetic field lines of force near the center of coil becomes almost parallel. We saw this, and around the hole at B, line of force are in clockwise direction. This is the pattern of magnetic field lines in the above activity. The line of force enter the coil from the side of experimenter. If the experimenter is seeing, so we can say that the face of coil towards the experimenter act as south pole, and the face opposite to the experimenter acts as north pole. Now relate the above observation to the flow of current in the coil, then we can say if the current flows in the coil in clockwise direction facing the experimenter, then the face of coil will act as a south pole. And if the current flows in the coil in anti-clockwise direction,